study of octopus DNA may have solved an enduring mystery about when the rapidly melting West Antarctic ice sheet last collapsed, unlocking valuable information about how much future sea levels may rise in a warming climate. The innovative research focused on the genetic history of the turquoise octopus, which lives on the seafloor across the Antarctic, and what it could reveal about the geology of the region over time. Tracing past encounters across the species, various populations suggested the most recent collapse of the ice sheet occurred more than 1 lakh years ago during period known as the last interglacial something. Geoscientists suspect but had not been able to confirm definitively, according to the study published Thursday in the journal Science. This project exciting because it offers a brand new perspective to solve a long-standing question in the geoscience community, said lead study author Sally Lau, a postdoctoral research fellow at James Cook University in Australia. DNA of living animals today contains all information about their ancestors in the past, so it is like a time capsule, she said. The research team arrived at its findings by sequencing the DNA of 96 turquoise octopuses that had been collected by institutions around the world and through fishing bycatch over the years. The oldest samples dated to the 1990s, but when sequenced, their genes provided what was essentially a detailed family tree going back millions of years. The DNA analysis enabled researchers to understand whether different populations of turquoise octopuses had interbred and what point that interbreeding had happened. It is like doing a 23andMe on the octopus, Leo said, referring to the genetic testing company. This information gets passed down from parents to children and grandchildren and so on. Today, population of turquoise octopus in the Weddell, Amundsen and Ross series area separated by the continent-sized West Antarctic ice shelves and cannot intermingle. However, the study suggested that there was less genetic connectivity between this population around 1,25,000 years ago, during the last interglacial when global temperatures were similarly to today's. This finding indicated the West Antarctic ice sheet had collapsed during this time, an event that would have inundated coastal region but opened up ice-bound areas on the seafloor that the octopuses would be able to occupy, ultimately encountering and breeding with members of turquoise populations that were once geographically separated from one another. What makes West important is that it's also Antarctica's current biggest contributor to global sea level rise. A complete collapse could raise global sea levels by somewhere between 3 and 5 meters, said study author Jane Stangl, professor and director of the Center of Sustainable Tropical Fisheries and Aquaculture at James Cook University. In a statement, Stangl first came up with the idea to use genomic methods to investigate whether the ice sheet had collapsed during the last interglacial. Understanding how the West was configured in the recent past when global temperatures were similar to today will help us improve future sea level rise projections, she said. Why octopus? The team chose this species of octopus for the study because the animals are relatively immovable. They can only crawl along the seafloor, which means they are more likely to breed within their genetically distinct local population. By contrast, a fast-moving marine species such as krill would have more homogeneous DNA, blurring out historical genetic connections, Lua said. Plus, the biology of turquoise octopus was relatively well studied and scientists understand its DNA mutation rate and generation time, which are crucial for accurate molecular dating, Love added. BN Nazif report.